In this video, we are going to learn how to factor by substitution in what I call hidden factoring. So let's get right into an example. I want to factor parentheses 4a squared plus 3, that quantity getting squared, minus 9 times that same quantity, 4a squared plus 3, and then finally this extra minus 36 outside. So what I notice is, well, I see this same quantity in parentheses showing up in multiple spots, this 4a squared plus 3. And when I see the same complicated thing show up in multiple spots, that's a tip-off to substitute for it. To substitute, so I'm going to introduce a new variable. So I can't call the new variable a because I already have an a in the problem. So maybe I'll call it u, and I'll let u be that quantity, 4a squared plus 3. And when I do that, when I let u be that thing, now anywhere that I see 4a squared plus 3, I'm going to replace it with a u. So that's going to give me first u squared, and then minus 9 times u, and then minus 36. So what we started with equals this. So substituting for this complicated looking thing that I saw in multiple spots, well, it turns it into a simpler looking expression. This now actually just becomes a regular old quadratic. Okay, and we know how to factor things like this. So I want to give you a chance to do a quick pause for 1 minute and try to factor this quadratic. So pause it in 3, 2, 1, pause it and try this. Okay, so hopefully you did that. Hopefully you paused it and tried it. So remember, when I factor it, I'll get something like this times something like this. And I'm looking for two numbers whose sum is negative 9. They add to negative 9. And their product is negative 36. And it turns out what works is minus 12 and plus 3. Okay, so I got this quadratic factored, but there were no u's in the original problem. So the last step is one of my last steps is I got to sub back in for what u equals. So anywhere that I see a u, I'm going to plug back in 4a squared plus 3. So I'll get that minus 12. And then in my next parentheses, I'm plugging back in for the u, 4a squared plus 3. And then I got that other plus 3. I could simplify each of these parentheses a little bit. Okay, now if I simplify them, the first one becomes 4a squared minus 9. And the second one becomes 4a squared plus 6. And I should ask myself, do either of these parentheses factor further? It turns out they do, and I want to give you another minute to try to factor them further and see if you can finish this. So pause it in 3, 2, 1, pause it, see if you can factor these further. Okay, so hopefully you did that. Hopefully you paused it to think about it. So the first parentheses, well, that's a difference of squares. I got a difference of squares. It's the quantity 2a getting squared minus 3 getting squared. So factoring that, I get 2a minus 3 times 2a plus 3. And in the second parentheses, I see 2 is common to each of these terms, so I can factor that out. I'll factor out a 2. And this is multiplying the previous stuff. And when I factor out 2, I'll be left with 2a squared plus 3. And we got it. Stylistically, when I factor out a constant like this, it's nicer to write it all the way in the front. Right? Because if I'm multiplying this times this times this times this, it doesn't matter the order in which I write all those terms. So let's move the 2 to the front. Times 2a minus 3 times 2a plus 3. Finally, times 2a squared plus 3. And that's as far as I can take it. Okay, we have one more practice problem here. I'm deliberately going to wait on this and have us try it together in class. But if you'd like to try it now, I'd highly encourage you to. It's definitely a step up in difficulty from some of the earlier ones we've tried.